Have you ever wondered what it would be like to step foot on a planet made almost entirely of gas? Well, today we're diving into the fascinating world of gas giants. These celestial titans are a breed apart, distinct from the terrestrial planets we're familiar with. Unlike the rocky surfaces we're used to, gas giants have a gaseous outer surface. Imagine trying to land on a cloud, and you'll have some idea of the challenges these planets present. But that's just the tip of the cosmic iceberg. Gas giants are an intriguing blend of mystery and majesty, with variations in their compositions, layers, positions, and locations within our solar system. These colossal planets with their swirling atmospheres and crushing pressures are a testament to the diversity and grandeur of the cosmos. So, are you ready for a celestial adventure? Join us as we journey through the cosmos to explore the colossal and mysterious gas giants. So, what exactly are these gas giants? Well, to put it simply, gas giants are a class of planets that are predominantly composed of hydrogen and helium. They are often referred to as Jovian planets, named after Jupiter, the largest and most famous example of a gas giant within our solar system. The term giant is no misnomer here. Gas giants are immense, often dwarfing terrestrial planets like our own Earth. For instance, Jupiter is over 11 times the diameter of Earth, and its mass is 2.5 times that of all the other planets in our solar system combined. But it's not just their size that sets gas giants apart. Unlike terrestrial planets, which have a solid surface you could theoretically walk on, gas giants have no discernible surface to speak of. Instead, they are composed almost entirely of swirling gases and liquids. If you were to dive into a gas giant, you'd simply descend deeper and deeper into its dense atmosphere, gradually transitioning into hotter and denser material until you reach the planet's core, if it even has one. So, what's inside these behemoths? Well, it's mostly hydrogen and helium, the two lightest and most abundant elements in the universe. In fact, these two elements make up around 99% of a gas giant's composition. The remaining 1% consists of trace amounts of heavier elements like carbon, nitrogen, and sulfur, as well as compounds like water, methane, and ammonia. The lack of a solid surface, the gaseous composition, the sheer size, and the potential for extreme weather conditions make gas giants fascinating, yet inhospitable worlds. Their unique characteristics continue to captivate scientists and space enthusiasts alike, providing endless opportunities for exploration and discovery. In essence, gas giants are colossal planets composed mostly of hydrogen and helium, with trace amounts of heavier elements. Now, we know that gas giants are composed mostly of gas, but what kind of gas exactly? Well, let's dive into the gassy world of these celestial giants. The two main components that make up most of the gas giant's mass are hydrogen and helium. Yes, the same helium that fills up those delightful party balloons. On a gas giant, however, the party is a little more extreme. Hydrogen and helium are the lightest and most abundant elements in the universe, so it's no surprise they constitute the majority of these planets. Think of them as the bread and butter of gas giants. Hydrogen, being the most abundant, makes up about 80 to 90% of the gas giant's composition, while helium accounts for most of the remaining 10 to 20%. But it's not just hydrogen and helium that make up these colossal planets. There's also a smattering of heavier elements present, albeit in smaller quantities. These heavier elements include methane, ammonia, water vapor, and even traces of rock and metal. It's these additional elements that give each gas giant its unique characteristics, like the vibrant bands of Jupiter or the stunning blue hue of Neptune. Now you might be thinking, wait a minute, how can there be rock and metal in a gas giant? Well, that's where things get even more interesting. These trace amounts of heavier elements are believed to reside in the planet's core. The core of a gas giant is thought to be quite different from the gaseous outer layers we see. It's believed to be incredibly dense and hot, made up of rock and metal under extreme pressure. The pressure is so immense, in fact, that hydrogen gas in the core is compressed into a form of metallic hydrogen. This metallic hydrogen is not like the kind of metal we're familiar with on Earth. It's a state of hydrogen under such extreme pressure that it behaves like an electrical conductor, much like metal does. So when we talk about the composition of gas giants, we're not just talking about a simple mix of hydrogen and helium. We're talking about a complex structure, with a dense core of rock, metal, and metallic hydrogen, surrounded by layers of hydrogen, helium, and a medley of other elements. These elements interact in fascinating and complex ways, creating the dynamic weather patterns and stunning visual displays we see on these planets. They contribute to the intense magnetic fields, the swirling storms, and the beautiful, colorful bands that make gas giants such a fascinating area of study. In the end, the composition of gas giants is much more than just gas. It's a symphony of elements, each playing their part in the grand cosmic orchestra. So, while we call them gas giants, they are really a fascinating mix of hydrogen, helium, and a cocktail of other elements. We have 4 gas giants in our very own solar system. Can you name them? Let's start with the largest and most well-known, Jupiter. The 5th planet from the Sun, Jupiter is often referred to as the king of the planets due to its massive size. In fact, it's over 11 times the diameter of Earth and contains more than twice the matter of all the other planets combined. Jupiter's swirling cloud patterns caused by its strong winds and rapid rotation are a sight to behold, with the Great Red Spot being a particularly iconic feature. This massive storm, larger than Earth itself, has been raging on Jupiter for at least 400 years. Next in line is Saturn, the 6th planet from the Sun, and the 2nd largest in our solar system. Its most distinctive feature, without a doubt, is its stunning ring system, composed of ice particles and small amounts of rock and dust. These rings span up to 200,000 kilometers, yet they are extremely thin, measuring less than 1 kilometer thick. Saturn, like Jupiter, is a gas giant primarily composed of hydrogen and helium. Moving further away from the Sun, we find Uranus, the 7th planet in our solar system. Uranus is known as an ice giant because, unlike Jupiter and Saturn, its atmosphere contains a higher proportion of ices such as water, ammonia, and methane. This composition gives Uranus its distinctive pale blue color. Uranus is also unique due to its extreme axial tilt, which causes it to have very unusual seasons. Last but certainly not least, we have Neptune, the 8th and furthest planet from the Sun in our solar system. Like Uranus, Neptune is an ice giant with a deep, thick atmosphere rich in methane, which gives it its striking deep blue color. Neptune experiences the strongest winds of any planet in our solar system, with speeds reaching up to 2,000 kilometers per hour. Each of these gas giants has numerous moons. Jupiter and Saturn, for instance, boast over 60 each, with several of them being larger than the planet Mercury. Uranus and Neptune, while having fewer moons, still host unique and fascinating lunar landscapes. These 4 gas giants, Jupiter, Saturn, Uranus, and Neptune, are not just distant, mysterious worlds. They are integral parts of our solar system, influencing its structure and possibly even the conditions that led to life on Earth. Each one is unique, with its own set of characteristics and mysteries, yet they all share the commonality of being gas giants, immense planets with deep, thick atmospheres and no solid surface. These 4 gas giants, each unique in its own way, make up a significant part of our solar system. While they share many similarities, each of our solar system's gas giants has its own unique characteristics. Let's start with Jupiter, the largest of them all. This giant stands out with its Great Red Spot, a storm so massive that it could swallow the Earth 2 times over. This storm has been raging for at least 300 years, a testament to the incredible atmospheric dynamics of Jupiter. The gas giant's strong magnetic field and magnetosphere, the largest in the solar system, also make it unique. These features make Jupiter a natural laboratory for studying the nature of planetary magnetic fields. Moving on to the jewel of our solar system, Saturn. Saturn is famed for its spectacular ring system. These rings are mostly made up of ice particles with a smattering of rocky debris and dust. What's fascinating is that despite their grand scale, the rings are remarkably thin, only about 1 kilometer thick. Saturn's rings are a celestial spectacle, a complex and delicate system shaped by the gravitational pulls of Saturn and its many moons. Next up is the sideways planet, Uranus. This gas giant is unique due to its extreme axial tilt of about 98 degrees. This tilt causes Uranus to have the most extreme seasons in the solar system. For about a quarter of the Uranian year, equal to 84 Earth years, the sun shines directly over each pole, leaving the other half of the planet in a long, dark, icy winter. This unusual orientation might be the result of a colossal collision that knocked Uranus on its side. Last but definitely not least, we have Neptune. Known as the windiest planet in our solar system, Neptune's winds are of legendary proportions. They whip around the planet at speeds of up to 2,000 kilometers per hour, much faster than any other planet's winds. The source of these extreme winds remains a mystery, but they contribute to Neptune's dynamic and active weather system, including the formation of giant storm systems similar to Jupiter's Great Red Spot. These unique characteristics aren't just for show, but they provide critical information about the formation and evolution of our solar system. For instance, Jupiter's Great Red Spot gives us insights into atmospheric dynamics and stability. Saturn's rings offer us a miniature model of a disk galaxy or a protoplanetary disk. Uranus's tilt helps us understand the impacts of planetary collisions, and Neptune's winds challenge our understanding of atmospheric dynamics and energy sources. In addition to these, each of these gas giants hosts a myriad of moons, each with its own unique geology and potential for life. Jupiter's moon Ganymede is the largest moon in the solar system and has its own magnetic field. Saturn's moon Titan has lakes of liquid methane and ethane. Uranus's moon Miranda features an unusual patchwork surface, and Neptune's moon Triton has geysers that spew out nitrogen. The gas giants of our solar system, each with its own unique set of characteristics, are more than just distant, beautiful points of light in our night sky. They are dynamic, vibrant worlds that continue to challenge and fascinate us as we push the boundaries of our knowledge and exploration. Each of these gas giants, with their unique characteristics, adds to the diversity and intrigue of our solar system. Today we've taken a journey through the cosmos, exploring the fascinating world of gas giants. These celestial bodies, massive in size and mystifying in nature, have intrigued us for centuries, and today we've delved deeper into their secrets. We started our voyage with a simple question: what are gas giants? These are planets much larger than our Earth, with a gaseous outer surface that makes it impossible to land or walk on them like terrestrial planets. They are called Jovian planets, named after Jupiter, the largest planet in our solar system, and a perfect example of a gas giant. We then dived into their composition, understanding what makes these giants tick. Predominantly composed of hydrogen and helium, the same elements that make up our Sun, these planets are more like mini-stars than traditional rocky planets. But beneath their gaseous outer layers, they conceal a core of heavier elements, a testament to their complex and intriguing nature. Our journey continued as we navigated through our own solar system, home to 4 of these gas giants: Jupiter, Saturn, Uranus, and Neptune. Each of these giants holds a specific position within the solar system, their orbits carefully choreographed in the grand cosmic ballet. And finally, we delved into the unique characteristics of each gas giant. Jupiter, with its iconic Great Red Spot, a storm that's been raging for centuries. Saturn, with its spectacular ring system, composed of countless particles of ice and rock. Uranus, the icy giant with its peculiar tilt. And Neptune, the furthest gas giant from the Sun, known for its intense blue color and ferocious winds. As we conclude our journey, let's marvel at the colossal and mysterious nature of these gas giants. Their existence challenges our understanding of the universe and inspires us to continue our quest for knowledge. Next time you gaze up at the night sky, remember the colossal and mysterious gas giants that are out there, silently spinning in the vast expanse of our solar system.